Welcome, Crater fans. This is a talk from Crater Remote Conf Mobile Edition. This talk focuses on building mobile apps using JavaScript. You can find out more information about upcoming Crater Remote Confs at conf.crater.io. Enjoy the talk. All right, welcome back, everyone, to our third talk of the day. This will actually be the last talk today. James Baxley could not make it to speak. He had a family emergency come up yesterday, so gonna talk to him once he gets that resolved and see if maybe we can schedule a makeup session next week or the week after and get that talk, because I think it's really, I hope he can do a makeup session, because I think I want to see that talk of going from Cordova to React Native and see what that process looks like. But our next talk, I've been super excited about. I want to get into game development, and I found Ken Wheeler. He works at Formidable. He works at Walmart on their various projects that they have there, and he's been doing React Native for a while, and so he agreed to do a talk showing us how to build a game with React Native. So I will turn it over to Ken. Welcome.
What up? Hi, my name's Ken Wheeler. I work at Formidable, where we do all kinds of open source, and I work at Walmart Labs through Formidable, where I'm on the React Native team, where we build React Native experiences for the Walmart iOS app and Android app. But I'm here today to talk about something a bit more fun, which is game development, particularly with physics in React Native. Ever since I was a little kid, I have loved video games, and I love video games to this day. I played Fallout for like 2 hours last night. I just love video games so much. And I've also been programming since childhood and have always tried to make games. I'm not that great at graphic design or, authoring game experiences, stories, mechanics, etc. I see that chat window, Fallout 4. Stop it. So, I mean, way back, I had made video games in Visual Basic or what have you. Eventually, tried some web gaming, but, perf wasn't really there. And more recently, right, got into React big time, React and Flux and all that stuff. And then React Native came out, and I was like, wow, this is great. But you see, like, the lion's share of mobile apps, right? They're very like Twittery or Facebooky, and that's not to take anything away from it. But they're for displaying information. They're for displaying lists of things or form inputs, or you have some more novel ones, some really cool stuff you see Snapchat doing with the real-time video manipulation and everything like that. But a lot of the apps that I was seeing were apps, not games. And I always want to try to make games, so I said to myself, how can I make a game with React Native? Because now I can make games for the phone and not have to write it in Unity or SpriteKit or what have you. I can write it in not only in JavaScript, which I enjoy, but React, which I really enjoy. But there's challenges around that. So we can explore some of those and some basic game dev stuff today. Is my screen showing? Yeah, so I've been working on this repo for a couple days now, and we are going to make this public right now. Blow! Thank God I didn't have to type that in. All right, so if you guys want to check this out, originally what I wanted to do was make like a game kit framework. That's still kind of in progress. It hasn't been frameworkified yet, but this is what we're going to review today. And this is a great example of, how to do this. I haven't seen anybody else do this, so I don't know if this is the way to do this, but it's how I'm doing it and how I guess the only way to do this is now, and I'm, maybe we can make a great starting point for someone else who can do it better, who knows more about making games. Because I'd like to preface this with, I am marginally good at JavaScript, and I'm terrible at making games. But we got this work, so let's check it out. First things first, there's a little bit of a difference between making apps and making games, right? So in an app, it's going to load up, and you're going to do something. You're going to have like a router, or you're going to have async calls out to servers to get data. Not to say that games don't do that. Of course they do, but generally speaking, like the main framework of the game or the app. Nice job with that first star. So let's just look at some game dev basics really quickly here, right? So general game dev works off of a loop, right? So you have three phases here. Generally speaking, you have the initialize phase, you have the update phase, and then you have the draw phase, right? So down here you can see a cool little graphic. You start your game and you enter into this game loop, right? And then you're going to hop between states, right? So you have your menu, then the intro, and then you have your level. You beat your level, you go to this level, you go to the ending. This is a really high level because the game loop controls your timing. The game loop controls your physics. All of this is tied in here to this loop. So general game dev, right? You have this loop going where it's constantly checking if this or that happened, and you're going to go to this state or that state, and that's how you progress through your game, right? So Exponent, I don't know if you guys are familiar with Exponent, but Exponent.js is great. It's like a sandboxed app where you can run React Native apps and just push them right to your phone and play with them. Really, really cool stuff. But they had a contest, and I entered the contest, and it was a contest to make a cool app with Exponent. And I was like, yo, I'm making a game for this contest. And not only that, a classic game, an amazing classic game. And, I got it to work. I took this little video here. I basically made Duck Hunt for iPhone using React Native, right? So if we check this video out here, I called it React Hunt. We go here, we have our dog come out, ducks go up. You tap to kill the duck, then he comes up with the duck. And then if by chance you let a duck go, then your dog laughs at you, which is my favorite part. Just tons of fun. But there was actually no physics here. A lot of game development is a lot of sleight of hand, so to say. There's no physics in this. Now, we are using some other core game concepts here, like states, right? We're looking at spriting, right? So let's take a look real quick before I get into how physics work, and have a look here at what that code looks like in React Native, right? So this is pretty Spartan dependency-wise. We're not even using Flux. It's just React Native. I have assets here, and then I have our SRC. We look at our main.js, like we saw before with those game states, right? I have my initial, my intro, shooting, and the end, right? So we hop through here. We have a game stage. Let's hop down to what we have here, right? And I'm saying render game state. So in my render game state, I have case initial, case intro, shooting, and end. We have a couple different things like, you tried to shoot the bird, or the state changed, right? Which lets you hop to the next state here. You have your initial one. But generally speaking, this is what we're talking about here. This is the regular render, and then you render the game state, and there's that. So let's take a look at these states, right? I have my initial state, right? Which is, if we zoom this back, right? I just have a view and a text with React Hunt. I have a touchable opacity, which is a button around taps and ducks here, right? we say on press for the button, this.props on state change bind intro. So this says hop to the intro now. So the intro, all the intro is just an animation, right? The intro, if we watch here, is, stop it. It's just this dog walking out, right? And then hops in the bushes, blam. So we have our intro here. We're using animated, right? Which is how you animate things in React Native. So I come here, I say this state, step 0, dog left is animated value 60. And then here, I basically move the dog using animated timing, right? Have this down here, right? And I'll get to this in a second because we have status, sniffing, and diving. We're going to talk about spriting. So it goes through, it does the animation, and then it's going to hop back, right? And then you're going to enter shooting, right? In shooting, very similar sort of stuff. We hop down to our render method. You have a touchable highlight, right? So the entire stage is a button here. You have a view, which is our shooting area, and you have an animated view. The animated view wraps this duck right here, and this is going to go ahead and provide the duck animation, right? We have status, which controls the spriting, and an on-killed callback, which is when you click the duck, right? So this entire game, there's no physics. It's really just a bunch of callbacks. It's trickery at the end of the day, right? So the next thing that I want to talk about, probably more important, is spriting, right? So in addition to your game update loop, probably the second most important thing, if you want anything to look like it's doing anything, is spriting, right? So you can see these ducks flying in different directions, and the dog comes up and has a good time here. He comes up. The dog walks out, jumps in, right? So the way that this actually works, right, is this is a sprite sheet you're seeing here, right? This is one image, right? And inside of this image is all the different frames of animation that we have here, right? So we have different colored ducks, and they're, you're going forward, you're going, backwards, left and right. You got shot. We have the dog, he's sniffing, he jumps in. This is where he's laughing at you, right? And the way that I chose to do that in here, this actually has a lot more complex spriting than the main game we're going to talk about here today. But what I did was I defined an object, and the object's keys are the different sprite states that we could be working with, right? So we have sniffing, laugh, diving, caught, right? And then I have keyframes here. And the top, right, is the top position from the sprite. We're talking about top here, right? This is the background position. So we have, top 0, top -60. And then the keyframes are the X position of that graphic, right? And then it's going to iterate over this array of X positions, or lefts, so to say. And what that's going to do is really just take that image and move it over on a set interval, and it looks like animation. I mean, it is animation, but it's sprite-based animation. So here with this dog here, the dog state gets passed down with a prop, right? So I have default props is sniffing, so it starts with sniffing. But when you pass down a status prop, it's gonna change this dog state here, and then you're gonna have a set interval that is gonna go step through these keyframes, and there you have the dog right here. So really, what I'm doing here is I'm moving this dog from left to right and looping through the sprite at the same time. Makes him look like he's walking. Makes the ducks look like they're flying. This is spriting, and this is how spriting is done in React. But again, this is not how physics-based games are made. This particular game allowed me to do a bunch of callback trickery, and I wanted something more, right? So let's close this down for a second. I sat and thought for a very, very long time about the best way to do this. React rendering is sort of expensive, especially if you're blowing everything away, right? Not in a, I update a form field kind of way, but, a bunch of times, like, request animation frame style, it adds up. So, wrapping an update loop around the entire render was out of the question. It's not going to happen. Additionally, I didn't really have any physics to work with. So I had to figure out a way that I wanted to do the physics. Enter p2.js. I don't know if you guys are familiar with this, but p2.js is a 2D physics library for JavaScript. One of the only ones that I found that was reasonably sized and was not coupled to a renderer. And that's the most important part, that I can have this world exist, but not necessarily have to render it, or I can conditionally render however much I necessarily want to, right? This is an amazing library. We can go look at this. This is my favorite demo because I have a Jeep. It's the suspension. But it does a really good job of modeling physics. It also does a really good job of rendering it. Now, if you look at something on the web, right, they're doing immediate mode re-rendering with Canvas, right? But we're working with views. So it would be like the equivalent of, rendering to the DOM, where you're going to have elements, right? I wanted to figure out how I could get this and React Native to play nice, right? So just for comparison here, I want to show you, I made a very similar game as a precursor to this, because I was thinking to myself, my first option, right, was to bridge over SpriteKit, right? So SpriteKit in iOS is a way of making games, and I wanted to bridge SpriteKit so that I could get access to their physics, get access to all that stuff. But then I realized it's not cross-platform, and that's not going to work because I want to be able to make cross-platform games because we're using React Native. So this is Swift, and it looks close enough to JavaScript that we could probably see what's going on here. So I created a class called Game Scene here, which is a SpriteKit scene. You create your character, your floor, your background, all that stuff, and it's going to follow this pattern here. Your initialize right here. You're going to create your character. You're going to create your floor, create your platforms, etc. You're going to do that on did move to view. That's when you init. Additionally, this is your update function, right? So on an interval, this update function gets called. So in the game, I have a character that moves up and down in the Y plane, in Y space, right? But everything else is moving backwards. It makes it look like the character is going forwards, but in actuality, everything else is going backwards. So here in my update function, I say floor.position.x minus equals 3, background.position.x minus equals 0.1. In Swift, this is great, right? Because it'll just update it right there and you're good to go. And then here I could say if, if the frame and the character, if the character falls down a hole, right? So if the character is outside of the frame here, CG-rect contains point, then essentially we're just going to restart the game because the character, fell down the hole, right? Now this is how this is done in Swift. I'm going to show you how we can do this in React Native. So this right here is the repo that I just open sourced, and you guys can check it out along. You can just watch me mess around with this. You have index.ios.js and index.android.js, both of which are the same thing, right? In here, I import, React Native, and every React Native app, this, get rid of this thing here. App registry.register component is your React Native equivalent of React DOM.render, right? So in here, I have my main game, and I have dead, which is, the you died state. So I only have 2 states here, so it doesn't need much management. I have a you died, and, let's reset it, and a game state. We toggled, dead to be true or false, and, really just toggle between these 2 game states right here. And that's what this main wrapper looks like. It's pretty simple. We should probably run this. Ooh. Why am I in caps lock, bro? All right. So we can run this game to get kind of an idea of what we are talking about. All right. What's nice about newer versions of React Native is you can run it right from the command line. You don't even have to mess around with Xcode. I did briefly mess around with Xcode so that I can lock it to be a landscape orientation game and hide the status bar. But after doing so, you kind of just go back to business here and run it from the command line, and then you can stay in Atom or Vim all day long. I typically use Vim, but I decided to use Atom today because the highlighting is a lot better, and I can have multiple open projects like that. So let's hide our terminal here. We have our simulator that's loading up. We have this super fun React Native terminal that's going to town. Any day, folks, any day. So here's the game that we are going to look at how it's built today. And it is very, very sneaky. It's not a very impressive game at all, right? However, it is all React Native. There's no native code. It's all JavaScript. Let's go here. It's all JavaScript. And it uses physics, real physics, has collision detection, everything you could possibly want when making a relatively simple game. So here we load up. We have our character here. And this fella is using real physics with collision detection. Not a very impressive game. However, it is running at 60 frames per second, and someone with better graphic design capabilities and game authoring could probably use this same approach to make something pretty cool. So let's see how to do this, right? That's actually a funny story about the character. My 9-year-old brother designed this character with Quixels and came to me and asked me if I could make him a video game. And I told him I absolutely can. So I went into Sketch and recreated it out of blocks. But so let's see how to do this, right? So first of all, let's look at our depths, right? This has a little bit more depths than that other game, right? So we're using MobX. I'm not sure how familiar everyone is with MobX, but it is the jam. MobX React, which lets you hook into everything. P2, which we just showed before, and then React and React Native. We're using Babel preset React Native stage 0, which should actually probably be a dev dep, but I digress because of MobX's use of legacy decorators. So let's see what's going on here. First, let's look at MobX. I'd like to hop into this real quick because this is what makes this all possible. If you're familiar with React, you might be familiar with things like Flux and Redux, but MobX is pretty new, so I think it's worth talking about a little. So you can create a regular ES6 class like this, right? And with MobX, you import observable, right? And observable makes class properties, believe it or not, observable, right? So unlike Redux, where you have everything's based around the concept of immutability, this is completely immutable, right? So you mutate these on the spot, but they're observed. So everywhere that is working with them, it actually just works. I know it's crazy, but it's awesome. I assure you. You can use it with immutable data too, but it doesn't use it the same way that Redux does. So here in our game store, we create an observable object called character, which contains our character's position and angle, right? Another observable, background X. And then we have a method here, set positions, right? Position and background, where we set our character position and our background X to what's passed through the arguments. Now, I like to write these kind of methods. If I'm going to mutate these, I don't like to just mutate them in the middle of somewhere. I instead like to use a method so that I know where it's being mutated if it is, if that makes you feel any better. So there's the other part of this is having an observer, right? So your components can observe this. So let's back up for a second. Here is our main component here, right? Now, the biggest thing that I struggled with was how to actually make the physics and the update and React Native all play together well, right? So I have my physics in a totally separate file here, and I have an init method, right? We come down here, in component will mount, I create a new store, and then I call a init with the store, the dimensions of the window, the spikes, the step callback, and the collision callback. Spikes here is this.spikes positions. In our constructor, we're generating them. So I have a util over here that basically just randomly generates these positions, these left and top positions for our spikes, with a randomized left here. So in our constructor, I do my binding, which if you're doing ES6 classes, you're familiar with. I generate my spike positions, and then I pass them into physics, which is available via this init method. So let's back off of React for a second, right? So this is our physics file. We're going to do a couple constants here. We have our fixed time step, our physics to DOM scale, our character width and height, spike bodies, and the animation frame, right? Your options get passed through, then they're destructured, and now it's time to create a physics world. So the way that I was actually able to get this to work, right, is if you've worked with React, you understand that they use the virtual DOM, right? So they create a fake DOM to operate on, and then diff it, and then reconcile the real DOM with the diff from their fake DOM. I'm doing a very similar thing here, right, where I'm creating a physics world outside of what's going on in my rendering, and then I'm kind of just cherry picking from that and selectively rendering just the pieces that I want. If I rendered everything based upon this, it wouldn't be performant at all. But in order to get that to be performant, instead I'm going to run that on the side and then kind of just cherry pick what I need and render very, very selectively, right? So the first thing we do is we create a world, right? So you create a world here, new P2 world, gravity 0.25, broad phase. I'm going to do an SAP broad phase, which is a faster but less accurate broad phase, which is how they detect collisions and things like that. We have our collision constants. So you're going to create collision groups. These are constants for those. So the first thing that we're going to do after creating our world is we're going to create the floor, right? So we create a floor that's at the absolute left and the absolute bottom of our phone window. Then we're going to create a shape, which is a P2 plane. Right? The plane just goes on forever, just a floor. We set our collision group and our collision masks. We say that the collision group is floor and that it can collide with characters and spikes. We're going to add the shape to our floor body and then add the body to the world, right? And we're going to keep doing this with the character here, right? We create a character a little bit different now because it has mass. We have fixed rotation, which means that if I didn't fix the rotation, anytime that character hit anything, they'd start doing these weirdo backflips, which is not really what I want in this game. But if you wanted, like how we saw the car before flipping over, you can have that work. Then in here, we position them in the center, and right here we're gonna basically kind of just set it so that the character is standing on the ground. I mean, maybe I'll show the weirdo backflips. We'll see. So we create a shape, right? So we're going to use a box shape here. Set our collision groups, add the shape, add the body to the world. I create the same thing with background. Then for my spikes, for each of these, I'm going to go through and create a spike body, create a spike shape, set our collision groups, add them to the world, and push them to sprite bodies. And now finally we are at our game loop. This might look familiar from what we were seeing in Swift before. You have this update method, right? So this gets request animation framed here. Request animation frame is polyfilled in React Native. See down here, we start by requesting our animation frame. So in here, right, we get our game step. We call the game step right here, right, which makes the physics step ahead. And then we're going to translate our position. Now, here is where the magic happens. This is what I'm extracting out of the physics world, right? Anytime I operate on this physics, it's going to do all this physics business that I'm not smart enough to understand. But it figures out where the character is going to be. This character is on a slant, right? And he's chilling and he has mass. He's going to start slipping down it. And the physics is going to worry about that. I'm going to worry about rendering it. Here, what I'm doing is I am taking the physics to DOM scale, right? And I am multiplying it by the character.interpolated position, right? And what this gives me is the state of this character at each tick, right? Same thing with the background here. And then on my store, I call that method that we defined where we're going to set our character position and the background X, right? So now I'm basically just picking out the X and Y of the character and the X of the background, and that is giving me the coordinates that I need to render the smallest part possible for this physics to work, right? Then down here, I'm saying world on post step. So after each step, we're going to do this step callback, which I passed in. And on impact, right, we're saying if it's not the character or the spikes hitting the floor, if it's character hitting spikes, kill our animation frame and call the collision callback, right? So that's the basics of how to set up the physics here. The super simple physics, even though it's 131 lines of code, it's generally simple compared to the things that you could do. But this is going to handle all of my physics for me. So let's hop back to where we're at right now, right? So where were we? So I import character, I import spikes, I import background, right? You're not seeing any MobX here because if you observed those values and tried to render them and have a state-based render up here, it wouldn't be performant at all because it would be re-rendering everything every time, and we want it to be performant. We want to have a good time, so we're not going to do that. So we head back down here. Component will mount creates a new instance of our game store. We initialize it, right? And let's just hop down to render for a second, right? Again, we have the touchable opacity around the entire screen, right? And that's basically a button. So we're saying every time you click that button, right? Every time you click this button, you want this dude to jump. Yeah. So on press, I'm calling this.createForce, right? So here's where I can start to mess around with some of that physics. I'm saying this force Q is equal to 0 and 700. That's going to put 700 of vertical force on our character. The reason that it's queued is because you have to do it in this step callback, right? So you're gonna go update these values after the world step has taken place, and you can make sure that you have the right physics values. So I say if this.force Q, if we have a force Q, character.force equals this.force Q, and then reset our force Q so that it doesn't get reapplied, right? Also in our step callback, we're taking the spikes. Well, we are taking the background and the spikes and we're pushing them leftwards, but we're not doing that in the DOM, so to say. This is only in the physics world right here, right? These spikes never move. These spikes are static and they sit in the background. We're only moving the background. But in the physics world, these spikes are moving so that, the physics world is aware that these spikes are moving relative to the the character's current position. So I mean, we can sit here and screw around with this force if you wanted to. Or you go to 100 and it'll look ridiculous. You won't jump high enough, and we'll never be able to win the game. Man, this thing is really chugging. Yeah, see, so that's just a little punk force. You can't do anything about it. We could hop up to 1,000. See what's up over here. Now he's moon physics. Holla. There's a lot of important things that I'm not doing here, like click throttling. So you could click forever, and this guy will never come down. But if you're making a real reasonable game, you do that. Now you want to see some? I might just throw in some weirdo backflips just for funsies, just so we can see what's going on here. You can see if you take something like fixed rotation off. There's so many variables that you can tweak with the physics. It's ridiculous. Yeah, it probably doesn't really have anything to run into, so you might not do the backflips right now. But I digress. Where were we? Right. So then down here we have view styles equals stage. Right. So this is inside of that button. We're just saying, it's going to be the whole width of the screen. In here we render our character. And this is very important. We created that store, and we need to pass it as a prop to the character and the background so that MobX can work properly. It works when you pass the store down as a prop. Okay. Inside of the background, we have spikes, and I pass a spikes prop, this spikes position. So if we look at just spikes for a second, all spikes does is render the spikes, right? You have a view that is flex 1. Then here you say, getting phone calls out here, this.props.spikes.map, and you're just throwing a spike out there. We have a look at a spike. You're saying get position. So, really this is just our generated positions, and it's going to render this spike image right here. These don't move. They're very simple. It's just rendering a spike. If we look at a character, now we'll be able to see a little bit more of how that other stuff works, right? So we import our observer from MobX React Native, right? This shouldn't even be there. That's ridiculous. We import sprite from sprite, and then we have this observer decorator here. So this basically wraps this class here. And when you say this.props.store.character.position, when you have that observer on there, anytime that changes, it's going to update this component. So anytime you mutate the character position, this updates. So that's essentially what's happening there. So we have a view right here that just wraps our sprite, and it's really just used for positioning, right? We have our character, it gives them a height and width, and then we're creating a transform of translate X and translate Y that's based upon the character position that is getting updated in the store. We have a sprite. We saw before we were doing the spriting. The sprite is very simple. I say sheet is an array of these sprites here. I have in assets, I have this little character walk cycle. And then here, I mean, it is literally just going through, calling a set interval, and looping through these indexes from 0 to 3. Then down here, rendering an image with the sheet with the array index of our sprite index, and it really just loops through your images and creates this animated character walking. So we have a wrapper around it that's positioning it, and then it's kind of just an image that's just cycling through an array of images, and that's how you get this right here, right? Head over, take a look at background. Again, this has an observer because the background's moving, and this is kind of trickery right here, and I'll show you why. Really, the same way we're positioning the character, we have our view here, right? When we move it leftwards, this entire thing is just moving to the left, right? Rather than moving each one of the sites individually and taking on that kind of overhead, I just wrap them in this background component and move that. And as long as they think in the physics world that everything is in the correct position, all your collision detection is going to be accurate. But the only rendering overhead that you're accruing is setting this translate X on that view, right? And that works great for static bodies, right? So if you had if this character had ledges you could jump on, or there's holes in the ground, or cactuses or something, that's fine and good. That all can work right here. They're all static bodies. If you have dynamic bodies like enemies, you're gonna have to set them up like the character, because they probably want to move around or have to track themselves independently. And that is really the long and short of how to very simply get physics working in a React Native game. I hope somebody watching this, is good at making games or good at graphic design, and they can take how I figured out how to actually do this and maybe make something actually playable. Then I'll download it and we'll have a good time.
And now, a brief word from our sponsors before you see the rest of the talk. Raygun. Spend more time building great software and less time fighting it. Raygun helps keep a watchful eye on your web and mobile applications and tells you when problems arise. You can learn more at raygun.com. NativeScript, backed by Telerik by Progress, is an open source framework for building truly native mobile apps with TypeScript and Angular 2. Use your web skills to get native UI and performance on iOS and Android. Enjoy the rest of the talk.
Awesome. Thanks, Ken.
Thanks so much for having me.
Yeah. All right. It looks like we've got a couple questions here. If you guys have more questions, do remember to queue them up on the left. We'll start going through these, though. The first one is maybe related to Meteor. So a lot of my audience comes from a Meteor background. I don't know if it makes sense here. Is game development with Meteor and React Native a significant departure from traditional game development? I guess we'll just throw away the Meteor part.
Hugely.
Yeah.
It's not really designed for game development. Huge. It's not really designed for game development at all, right? You really have to kind of trick it a little bit to be able to do this right. If I was a real game developer, if I knew anything about game development, I might do it in Unity or Swift or what have you. But I mean, if you take something like Spriting, and I've tried to write games with Spriting, this performs better on the simulator than Spriting games do, or at least in my experience. Maybe I just write bad Swift or something, but it's a big departure as far as how this is structured, because most game dev is like immediate mode rendering, not maintaining this tree of, you're much more integrated into the physics world. If you're doing something like Canvas or GL or something, it's not like you're doing like tree diffs on like a DOM tree, so to say. That's why I have you see like Canvas games, like some of those Canvas examples for P2 are bananas. They run crazy smooth in the browser. That's why. So should you make games in React Native? Some games, if you want to make a game, you can, you're not going to go make a, Pokemon Go or anything. But, if you want to make a simple game, especially you want to do something easy, like, I don't know, like not easy, but if you want to make something that's not so animated, like 2048 or something. Oh, it's like a perfect choice for something like that. Going through your game states, or even something like Tiny Wings or Flappy Bird or something. You're good to go. even some turn-based strategy even works. But as soon as you want to do like 3D Skateboard Simulator Pro, maybe looking at something else.
Yeah, and like I'll also say tomorrow we get a talk from Pablo, who's going to show us how to use Phaser, and he's going to walk through building kind of like a Mario clone.
That's awesome.
Phaser and Cordova and that kind of thing. So that's going to be interesting to see as well. So Ryan asked, I know this could be a big question, but could you briefly explain what Get Animation Frame is and does?
So it's request animation frame, and in the browser, it's how you animate, right? So request animation frame, when you call request animation frame and give it a callback or what have you, it's going to call that back on the next available animation frame that lets you do performant animations, right? So then, the idea being you call request animation frame, you do your function, right? Whatever you want to do, like you step a character left, and then you call a request animation frame with the same function again. So it's a recursion, so to say, not like a deep recursion, but more of a loop. And what it's going to make sure is that you're operating on the right ticks for performance. And then outside of that, you manage like different state variables, like something, or even inside of it, right? You'd like do like a decrement, like var x minus equals 5, and then next thing you know, it'll give you 60 frames per second. Now that's polyfilled for React Native. I'm doing a time step, but the React Native request animation frame runs like 1 billion times per second, literally 1 billion. But yeah, it's significantly faster than the web. I can't hear you.
I'm muted. Sorry.
Oh, sorry.
There was a train coming by and I'm muted. So yeah, that was a good answer. Dave asks, are there things like a COD, something that might make its way to React Native? I actually hadn't seen this library before, but
yeah. So here's the thing: is it going to make its way into React Native Core? Probably not. React Native Core, at least from what I've heard from the React Native Core guys personally, is that they want core to be small and tight, a tight set of core componentry to work with, and then with the opportunity for the community to then go ahead and build really cool things for it, right? So they're relying on the community to build up these different components, these different additions to React Native. Could that be in a React Native version? Sure, absolutely. I've seen React Native versions of things you wouldn't even believe. We have at Formidable, we have a charting library called Victory, which we did in SVG. And it turns out you have React Native SVG, which lets you render SVG, and it basically bridges SVG code to, on iOS, it does, core graphics code, right? So, we were able to reuse a ton of code, and now our charting library works on iOS, and it uses core graphics, but it's technically using SVG markup. So, yeah, I think that could definitely make its way. I've seen some people do some stuff with React Native in that respect. So, I mean, yeah, sky's the limit. With what I always tell everybody, especially at work where we're doing React Native, it's there isn't anything that you can't do with React Native if you're willing to get your hands dirty with Objective-C enough.
all right. Crypto Quick says, okay, cool, now make Pokemon Go.
Actually, I mean,
there's nothing really that, like, you don't even need collision. I guess you do when you throw the ball.
You don't need collision. No, not even. I mean, you might want physics for the ball to go.
Yeah.
But I mean, you have access to the gyro. You have a camera. You can lay things on top of the camera. You have geolocation. there's actually no real reason that you couldn't do it.
Yeah.
Oh, I see the comments. No, that's definitely physics because I've been making some crazy trick shots. Crazy trick shots.
Nice.
But yeah, I mean, you probably could do it.
Yeah. So now I'm curious. I didn't put this in as a question, but like if someone wants to learn more about spriting and animation and that kind of thing, like where would you suggest they go to get started on that?
I would just Google game development, and there's a lot of like intro to game development. I mean, this is like, you know, core game development concepts, so it's going to apply to anywhere you're really trying to do it.
So on that React Hunt game, you built that one?
Yeah.
Okay. Were those sprites like pre-made, or did you make those yourself, or?
Those were the original sprites from Duck Hunt.
Oh, okay. Yeah, they look
so I managed to obtain.
Nice. Fun.
Courtesy of the internet.
Courtesy of torrents.
Yeah, that's why that game looked so cool, because it was the original
Duck
Hunt graphics. I wasn't in charge of the art department, so that's why that one looked a bit more polished.
Oh, nice. Yeah, so someone just linked to Piskel, which is a art and animated sprite app.
Oh, cool. Look at that.
Yeah. It looks like you can even like preview the animations.
Nice. I'm about to go make some sweet pimp walk cycles.
Indeed. Like my daughter keeps asking me like, how do I get into the graphics of gaming? And I'm like, I don't know. I'm not an artist. I can write code.
That's a deep dive. Next thing you know, you're in Maya.
I'm out. Nice. All right. Well, it looks like we got through all the questions. I just want to say thank you, Ken. Really appreciate you coming on and sharing that with us and doing all that research and then open sourcing it. So that was awesome.
No problem, dude. Thank you so much for having me. It was a pleasure to come talk. Yeah.
And
hang out and talk.
Yeah. If anyone has any questions, Ken is in the Slack chat room as well, so you can hit him up there and ask him, or find him on Twitter. And
you can yell at me on Twitter whenever you want.
Yeah. I love following you on Twitter. Funny tweets. Yeah, and so like I said, I'll let everyone know what happens with the makeup session that should have happened like right now, but and we'll pick up tomorrow at 1 p.m. Eastern, and we'll get started. Yeah, we'll post the
link. Somebody's knocking at my door. Sorry, dude.
All right. See you guys tomorrow. Thanks for watching this CreatorConf talk from the Mobile Edition 2016. For more information about upcoming conferences such as the one in February 2017, go to conf.crator.io to learn more.